You're doing section 6.6, which is solving absolute value inequalities. In the previous section, we solved absolute value equations. So we took whatever was in the absolute value and set it equal to that number and the opposite number. This time it's pretty similar. So we keep the same one, just like we did for the equations. But when we switch the sign on the number, we also have to switch the inequality symbol. So when we have x is greater than or equal to 6, that turns into x is greater than or equal to 6 and x is less than or equal to negative 6. And then the only other difference is we're going to end up having to graph it. So less than negative 6 looks like that. And greater than 6, greater than or equal to 6 looks like that. So B, absolute value of x is less than 0.5. So we have x is less than or equal to 0.5 and x is greater than or equal to negative 0.5. So if I think about what this would look like, here's negative 0.5 and here's positive 0.5. If we're going to be greater than or equal to negative 0.5 and less than or equal to 0.5, it's going to be right in between the two. Okay, and on C, we have the absolute value of x is less than or equal to 8. That's going to be x is less than or equal to 8 and x is greater than or equal to negative 8. So again, we're going to have these two values, and if we're thinking about what these two inequalities mean, we're going to have all of the values in between. If we're greater than or equal to negative 8 and less than or equal to 8, that's all the values in between. D, absolute value of v is greater than 2/3. That would be v is greater than 2/3 and v is less than negative 2/3. So here's 2/3 and negative 2/3. We are greater than 2/3 and less than negative 2/3. Okay, so we're going to have a couple definitions here. The first one, if we have an expression, ax plus b, inside our absolute value, then that's less than some value c. That is equivalent to negative c is less than ax plus b is less than c, which is an and inequality. And if you notice on the previous page, we had two and inequalities in the middle. When we graphed it, they come together. That is because we started with a less than inequality. If we have absolute value of ax plus b is greater than c, that is equivalent to ax plus b is less than negative c, or ax plus b is greater than c. So if we start with a greater than inequality, we know we're going to end up with an or inequality. Okay, so right away we have absolute value of x minus 5 is greater than or equal to 7. This tells us we're going to have an or. So I can take my x minus 5, leave one exactly the same, greater than or equal to 7, and then when I do the other one, I switch the inequality and make it negative, and then I solve both of them individually. Get x is greater than or equal to 12, and x is less than or equal to negative 2. Here's 12, we're greater than, and negative 2, we are less than or equal to. Solve the absolute value of negative 4x minus 5 plus 3 is less than 9, and graph. So before we figure out if it's an and or an or, we have to isolate the absolute value. So I need to subtract the 3, get rid of that, and then we have the absolute value of negative 4x minus 5 is less than 6. And now we can say, okay, since we have a less than, this is going to be an and inequality. So we take the opposite of the number on the outside, which is negative 6, say that that's less than negative 4x minus 5, which is less than 6. That's set up as an and inequality. And then we try to isolate the x in the middle to solve it. So to isolate it, we need to add 5 to all three sides. Negative 1 is less than negative 4x is less than 11. And then divide everything by negative 4. So remember what happens when we divide by a negative when we're having inequalities is we need to switch the inequality symbols as well as the signs. So negative 1 divided by negative 4, 1/4. Switch the inequality, x greater than negative 11/4, which is negative 2 and 3/4. So here's negative 2 and 3/4. Here's 1/4. It's in between because it's an and. And the last one, you're buying a new computer and find 10 models in a store advertisement. The prices are $890, $750, $650, $370, $660, $670, $450, $650, $725, and $825. Find the mean. So for mean, we just have to add them all up and divide by 10 because we have 10 numbers. So if I was going to add up all these numbers on top, divide by 10, adding all those numbers up on top, we get 6,640. When we divide that by 10, we get the average of $664. Okay, and that was section 6.6.